Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering geometry, lessons 4-2 and 4-3 on triangle congruence. These are the different vocabularies that we're going to cover today, and we're also going to be doing several of the questions from your practice. So let's get started. In 4-1, we learned that if you have all of the sides of a figure congruent and all of the angles of a figure congruent, then both of the figures are congruent. So we learned all the sides and all the angles make for two congruent figures. Today, we're going to learn a little bit about triangles and how you don't have to have all of the sides and all of the angles. You just have to have some, but in very specific ways. So our first one is called SSS, which stands for side, side, side. So if you have all three sides of two different triangles congruent to each other, then you can prove the triangles are congruent. So here is one side here in yellow. Here's another side here in green. And here is our third side here in red. Notice all three sides of all three parts of each triangle are congruent. Therefore, we can say that these triangles are congruent to each other. Our congruent statement is still important, though. The way that you name it does matter. So in here, I picked triangle ABC is congruent to triangle XYZ. Here are some problems from your practice. It says the image above has enough given information to prove that triangle PQT and SQT are congruent by side, side, side. So notice here they've given us one side, two sides, but they did not give us three sides. And there's no other information given that can prove that PQ and QS are congruent. Therefore, this question is false. Here's another question. They want to know if this could be proved by side, side, side. So here we have one side and two sides that they've given us. And then the third side of the triangle is actually the same. PR is the same for the left-hand triangle and the right-hand triangle because of reflexive property of congruence. So this can be proven by side, side, side because we have all three sides of both triangles. The next way that you can prove triangles congruent is if you only have two sides and one angle, and it's called SAS or side angle side. It is important to note that the way that they've written this down have the sides on the outside and the angle in the middle, and that holds true from the triangles. So you have a side and another side, and you have to use the angle in the middle between those two sides. So here's a side and another side with the angle between those two sides. So these triangles are congruent by side angle side. And I wrote our congruent statement below. Remember that the order does matter. So here's one of the problems from your homework. It says, what other information do you need to prove that the two triangles in the image below are congruent by either side, 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 or side angle side? So in the figure, they've given us one side and one angle. So since they've given us one side and one angle, it seems like SAS might be the easiest way to go. So we have one side and one angle. I would need the other side that forms that angle on the other side of that angle. So that would be LG and MN. So this one is the correct answer for that problem. And here's another one. Can we prove these by side angle side? So it looks like they've given us one side here, and they've given us two sides there, and then here they've given us an angle. And this is not possible by side angle side because the angle is not between the two sides. In order for that to happen, we would need to use angle E and angle P because that would be the angle between the two sides. So this one is not possible. Here's another option here. They've given us one side here. They've given us an angle here and here. So for side angle side, we would need the side next to it. So we'd start here with this side, go to this angle. We would need this side right here. Start on this side, go to this angle. We would need this side right there. And MK is congruent to MK because of reflexive. So yes, this can be proven by side angle side. Now, if you only have one side and two angles, you can still prove that the triangles are congruent. Again, in a very specific way though. Notice that the angles are on the outside of the side. The side has to be between the two angles. So here's angle 1, here and here. Here's our second angle, here and here. And we have to use the side between those two angles in order to prove by angle side angle. And there is our congruence statement. Here's some of our homework. It says name the two triangles that are congruent by angle side angle postulate. And it is a little bit difficult to see here. It looks like this one has a side and one angle and a side. So this one has two sides and one angle. So it's definitely not ASA. This one over here looks like it has an angle and another angle and a side. So that one could be ASA. And this one up here looks like it has two angles and two sides. So the blue triangle can be proven angle, side, angle. Notice the side in between the angles. And the yellow triangle could also be, because here's an angle and the side between the two angles. So the correct answer is triangles ACB and EFD. And here's another one. What else must you know in order to prove the triangles are congruent by angle side angle? So here we have an angle, and here we have a second angle. It's actually a right angle, but it's still an angle. So we would need the side between the angles. BC and EF would have to be congruent in order to prove this by angle side angle. And our last one is, again, if you have two angles and a side, but notice this one isn't angle side angle. This one's angle angle side. So this one, the side is not between the two angles. So as you can see here, we have one angle here and here. We have a second angle here and here. And then instead of using the side between them, AC and ZX like we would have before, we actually use a different side. And so this is how you prove by angle, angle side. And there's our congruent statement there. From your homework, what else must you know to prove these triangles congruent for angle, angle side? So here's a side, and here's an angle. And we need another angle because we need two angles and a side. So this one's out because it's talking about lines. So this one must be the correct answer. And to prove it, we have angle KHJ, which would be this one here in red, congruent to HKG, this one here in red, or you could also use this one here in blue. All right, the last ones here, you guys, they want to know if you can prove these by either angle side angle or angle angle side. So let's see what they've given us up top. They gave us an angle here. They gave us a side here, and that's all the information they gave us. But because we know that this here and this here are vertical angles, we do have two angles and one side, but it is not angle side angle because the side is not between our angles. So this one is angle angle side. And our last one down here on the bottom, they did give us a side. And we can prove that these angles are congruent because they're vertical angles. But that is all the information we can prove, and having one angle and one side is not sufficient to prove triangles congruent. I hope this helps everybody. Good luck. Have a great day.